This is the third video of the introduction to immunology. Sorry about how the last one ended. I have no idea what I said um, because I ran out of time. So like I was saying, the uh, the receptor is generated at random. Then we have tolerance to get rid of any autoreactives, and then what happens next is that the naive B cells or T cells then go out into the lymph nodes and wait. And they may wait the entire life of the organism and never be activated because you never run into whatever they were against. However, every once in a while, a pathogen will have an antigen whose epitope will activate the B cell or T cell receptor. Then we have a clonal expansion. There will be some cell signaling due to the antigen binding to the B cell receptor or the T cell receptor, and that will cause cell signaling within the that cell to cause it to divide. It'll divide into memory cells as well as effector cells. The effector cells will then either, if they're B cells, produce antibodies and become plasma cells, or if they are T cells, then go on to either attack the virally affected cell, or if they are CD4 T cells, maybe help the a B cell to do its clonal expansion. So, so the B cell and T cell receptors uh, are specific for antigens produced at random, and therefore create a wide variety of things that they are against. So the clonal selection hypothesis says that each lymphocyte has a single receptor that has a unique specificity. Interaction between the foreign molecule and the receptor is capable of binding with high affinity, and that will cause the cell with that receptor to differentiate into effector cells that are then activated and bear the receptor of identical specificity to those of the parental cell. And the lymphocytes that have that receptor are now specific um, against the antigen and can go on to do whatever um, uh, um, effect they're supposed to have, B cell or T cell, whichever it is. If they are against self, they will be eliminated through tolerance mechanisms, so that we won't have any autoreactive um, lymphoid cells. Um, and so a healthy individual should not have any B cells or T cells that are against self. And we will talk about autoimmunity later in the semester. We're also going to, this semester, talk about some of the lymphoid organs. The B cells will come out of the bone marrow, the hematopoietic stem cells that lead to uh, B cells are located in the bone marrow. And so all your B cells are coming from the bone marrow, and then they um, end up as naive B cells after positive and negative selection. They end up as naive B cells in the lymphoid organs, either the spleen or a lymph node, or adenoids or tonsils, or whatever. Um, the T cells um, develop in the thymus, and they also migrate to the lymphoid organs, the lymph nodes and the spleen. So we're going to talk about once the innate immune system has engulfed a foreign pathogen, how it migrates to the lymph organ. We're going to talk about what the specific cell signals that cause it to move to the lymph node, and how once there they are able to activate naive T cells to affect the reaction to that foreign antigen. We're going to talk about uh, the bridge between the innate immune system and the adaptive immune system, specifically dendritic cells. We'll talk about that this semester. We're also going to talk about the structure of some of the lymph organs, such as the lymph nodes, the spleen, the thymus, and the Peyer's patches. So that's what we're going to be doing this semester, and I hope that you got some information out of this chapter. Um, Generally, each chapter will have 2 or 3 videos, and generally each chapter will have maybe 10 questions on a test. So so be sure to go through the practice tests for chapter 1 to check how well you are doing on the information from these 3 videos, and any questions you have about the practice tests, bring them to the discussion section so that we can clear those up or go into more detail, elaborate, or explain, um, and hopefully we'll be able to utilize some of this information when we're looking at things like primary literature and case studies. So welcome to immunobiology, and I hope we have fun this semester.